Jock Robie, thank you so much for being here. We really appreciate it.
Thank you for having me again, Willie. What I'm going to do is start at the very end. And that's when you harvest your worm bin. And I'm going to demonstrate that so that you can see as you're putting your worm bin together and listening to the talk where it's all headed, as opposed to starting at the beginning and wondering where this is all going. We're going to start at the end, and then I'll back up, give the talk, and we'll put the worm bins together. But I want you to see why I emphasize some of the things that I emphasize. So the first thing I'm going to do is harvest a worm bin. I'm not going to go through the whole harvest because it takes about 45 minutes to harvest a worm bin. I don't want to use up 45 minutes doing it. But I am going to demonstrate. Probably it'll take about 5 minutes to do what I'm going to demonstrate. This is what a worm bin looks like. It has a lid, it has some holes in it for ventilation. I keep a log sheet with each of my worm bins. I have about 60 of them. So trying to remember when the last time I fed it, how much I fed it, what I observed and so forth. If I don't write it down, I can't keep track of it. But I have found that that's a good habit to get into, is to have a log sheet. So each time you work with a worm bin, you can add to your observations. The cover on the worm bin is what they call row cover or remay. It's held on with either an elastic strap like that or with a big rubber beam. The idea there is you want to hold the cover on good and tight so this is sealed well, so if there are flies on the inside or flies on the outside trying to get in, you keep them out. So this provides good ventilation, but it stops any insect travel, either frontwards or backwards. Then there's some dry newspaper that helps to keep the walls dry, and I'll talk about that in my presentation a little later. And then there's some plastic that holds the moisture in to prevent the worm bin from drying out, because worms need to have a moist environment to live in. And the newspaper, 2 sheets of newspaper on top, provides the worm playground. This is where a lot of the breeding takes place, is on top of that newspaper. And you want to increase your population of worms just as much as you can, because the more worms you have, the more food that you'll eat. So this is what the inside of a worm bin looks like. This was last fed 55 days ago. So it's been almost 2 months since this was fed. And you can see that what's in here looks like dirt, mostly dirt. This is all worm castings. What that used to be is all the kitchen scraps. That's what's left of a squash stem, okay? So some things take a long time to decompose, other things go very, very quickly. What I put into a worm bin is just a mixture of kitchen scraps, which includes coffee grounds and tea bags and any kind of fruit and vegetable. I don't put processed foods in. I don't put anything that's meat, fish, or dairy in, because when they decompose, they smell bad. So this is basically a composter for plant material. So after the worms have worked on it for a while, then it's time to harvest. And the way you harvest it, put it in a sieve. Okay, so now what you have is the worm castings, and here you have the worms and the bedding that they live in. Over here, this all will go back into the worm bin for another harvest cycle. So you do this about every 3 to 4 months. So it would take me about 45 minutes to go through this whole process and set this bin up for another harvest cycle. But one of the things I wanted to point out is the moisture level. This is what I call moist and crumbly, in that if I squeeze it like this and then I disturb it, like it would be disturbed on that sieve, it breaks apart. You can imagine if it's muddy, that wouldn't work. So if your worm bin gets muddy, you're not going to be able to harvest it this way unless you dry it out. The way you dry it out is you just mix the wet, muddy stuff with dry material, dry newspaper, dry peat moss, things like that. Let your worm bin sit for about 30 days. The excess moisture moves from the wet castings into the dry material, and then you can go ahead and harvest your casting. So it's not the end of the world if your worm bin gets muddy. It's a very common problem. But if you keep adding dry material with the food as you're feeding, you can manage the moisture and not let it get wet. What I normally do is I'll take about a quart of this when I'm done, and I'll put it back in with the worms. The worms actually require their own castings to provide the biology that they need for digestion. Now, most of this stuff has got enough in it that it would be suitable, but just to be on the safe side, I put a quart back in along with the worms. And another thing I do is I use nematodes, which are microscopic worms, to control fly larvae, and those go through the sieve. So when I scoop up that quart of material and put it back in, my nematodes are going back in at the same time. All right, so that's the end of the process. Now we'll go back to the beginning. Well, back in the 80s, my dad was doing this. And at the time, he said to me, "You want to see my worm bin?" And I said, "Sure." And we looked at it in the cellar, and I was raising 3 kids at the time. My wife and I were both working, and we just thought that was kind of interesting. But after I retired, and I had been kicking around for quite a few years, somebody gave me, as a Christmas present, a gift certificate for a worm bin. And I started in with that as my first worm bin about 2008, I guess it was. And I now have 60, and I have given away over 900.
Wow.
All populated from worms that came from the original 100 worms that went into that first worm patient. I got invited all over the state of Maine to start worm bins in various nonprofit organizations. And then, word of mouth just spread and spread and spread. And so I now do it for Ed All Dad, I do it for churches, I do it for schools, I do it for Willie. And on it goes. And we just have to keep the lid on it because it's so popular that I already don't have enough time to do what I do, and I get a lot more requests than what I have time for. So that's where we're at, trying to save the world one worm bin at a time. What is vermiculture, and what is worm composting? Vermiculture is worm farming. And worm farming has been going on for some time now. Back in the 1940s, 1950s, started doing it in the South primarily to grow worms for fishing bait. And that's how vermiculture really got established as a business in this country. But along about 1950s, 1960s, they started to recognize the benefit of growing plants in worm castings. Worm castings are the worm poop. Okay, this is the stuff that has been processed through the gut of the worm and is collected in this process here and then fed to plants. And what they observed when they fed this to plants was plants really grew very well. They didn't know why, but it was pretty extraordinary. And there was a lot of commentary about that, a lot of speculation. And I will go in a little bit to the science of it. But so worm composting has now become a commercial entity as well, not just growing worms for bait, but growing worms to convert what would otherwise be composted into worm castings, which are sold. Some people do this on a scale that they're doing 600 tons a day of worm castings. They have millions of worms. It's mechanized, and it's big business. It's done primarily in the Southwest, Southeast, and the Northwest because of the climate. Those areas don't have to have an indoor facility to do it. They can do it actually right outside, maybe cover it up with a shade shelter or something like that. But in the Northeast, you have to build a building and put it inside. So that's what vermiculture is, and that's what worm composting is. Now, why do it? These are just quick pictures to show the kind of growth difference that you see when you use worm castings with just regular potting soil. Half of those plants were grown in regular potting soil, and half those plants were grown with about 20% worm castings in the potting soil. So you see a lot more growth, and it works with lettuce, it works with arugula, same kind of difference. And we started then experimenting out in the garden to see what it would do in the garden, and we tried it on high bush blueberries. And this picture doesn't really show it as well as I'd like to, but what happens on high bush blueberries is you get more new growth. And each year when a blueberry puts out its new growth, that's where the blossoms and the fruit form. So the more new growth that you have, the more crop you're going to produce. So what the worm castings did was stimulate more new growth. So you ended up with more fruit. With my first experiment, I used on one blueberry bush 5 quarts of worm castings around the base of one plant, and I ended up with about 18 inches of new growth, and the weight of the blueberries was so much that it broke the canes. So too much, it's not necessary. You can put in too much. You can get too much new growth, and then you'll have a problem supporting your canes. So it does work on the blueberries. In addition, it also works on corn. It grows a very healthy corn plant. That's Silver Queen corn, and my reach is 7 feet 10 inches. Okay, it's about 2 feet taller than what we learned from this experiment. You don't eat corn plants, right? You eat the corn on the cob. It doesn't produce more ears or bigger ears or longer ears. If a corn plant is capable of, say, producing 3 ears, what the worm castings help is the plant is vigorous and strong enough to support those 3 ears. So you get a good crop rather than, say, a marginal crop if the plant was not as healthy and as vigorous. So it does help the corn. I don't have a picture for garlic, but I can tell you that a garlic experiment produced garlic bulbs that weighed 29% more on average than a control.